Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to calculate molarity and going over a couple of practice problems showing you how to do that. Now, this applies to any type of calculation when you're doing concentration. So in this case I'm going to be showing molarity, but it could be any sort of calculation, or I'm sorry, concentration expression that they're asking you to do, right? It could be molality, it could be percent by mass, percent by volume, it could be parts per million, whatever the case may be. You need to figure out what they're asking for and figure out what parts are there. In molarity, you want to figure out, okay, well, you need to know by definition what molarity is. You need to know that molarity is the moles of solute divided by the liters of solution. Once you know that, it's just a matter of finding those parts and putting them together. So if it's molarity, you need to find moles of the solute, and you need to calculate and find liters of the solution. If it's molality, then you need moles of solute, but you need to find the kilograms of solvent. If it's percent by mass, then you need the mass of the solute, and you need the mass of the solvent in that case, or I'm sorry, the mass of the solution multiplied by 100, right? So if you're given the volume of the solution and if you're giving the mass of the solution and you need the volume, you might need to be given density for that. So again, it all depends on what the concentration expression you need, and you need to know what that expression is and what the parts are that you need to get that expression, and then find that in your problem. So let's get into this. So for molarity, the first problem, they're giving us 734 grams of our lithium sulfate, and that is dissolved to make 2,500 milliliters of our solution. So we're given milliliters of our solution, and we're given grams of our solute. In this case, it's lithium sulfate. And they're asking us specifically for the molarity. Again, they could ask us for molality, they could ask us for the percent by mass, they could ask us for the mole fraction, for example, right? So in those cases, we need to know what the definition of those concentrations are, and two, look for that information in the problem. Whatever information that we need to find those parts must be in the problem. Okay, so molarity. We need to know what molarity is. Molarity is, right, represented by capital M, and that's moles of solute divided by liters of solution. So now that I know what the definition is, I can look for those parts. So I need to find moles of solute and I need liters of solution. If I don't have those, if they're not given to me directly in the problem, then I need to convert to get those units. So I need moles of the solute, liters of solution. What do they give me? They give me grams of the solute, lithium sulfate. So I don't want grams, I want moles. So I'm going to need to convert the grams to moles, and that is what I'm going to use molar mass for. So I need to calculate the molar mass of my solute, which in this case is lithium sulfate. So I need the formula for lithium sulfate. This is where the naming of compounds comes in. So if you don't know how to go from the name to the formula, then you're not going to be able to calculate the molar mass. If that is you, then please go to my other videos where I go over how to go from the formula of an ionic compound to the name, and from the name to the formula. Okay, so here, lithium sulfate, we're going to need to know the formula for that. So lithium sulfate, that's going to be Li2SO4. So that's my formula. And the molar mass of that, when I calculate that out, is 109,962. So the molar mass for this substance is 109 what did I say? 962 grams. 962 grams per mole. So I can use this as a conversion factor because I have grams per mole. So I'm relating grams and moles. So I can use that as conversion factor. So I'm going to take the 734 grams of my lithium sulfate over 1. Use the molar mass. So I have 109.962 grams of the lithium sulfate on the bottom and 1 mole of the lithium sulfate on top. So grams are going to cancel out. Now I have moles. So now all I need to do is the calculation, and I came up with 6.68. So 6.68 moles of my lithium sulfate. Lithium sulfate. So I got my moles now. So that's half of it. Now I need liters of solution. They gave me 2,500 milliliters. I want liters, not milliliters. So I got to convert milliliters to liters. So using that, I know that one liter is equal to 1,000 milliliters. So I'm going to use that to convert. So I'm going to start with the 2,500 milliliters of the solution that they gave me. So this is my solution, and over 1. And I'm going to use my conversion here, my conversion factor. So 1,000 milliliters goes on the bottom and 1 liter on top. Milliliters cancels out, and I get 2.500 liters. Or in this case, just 2.5 liters is going to be good. Now I have my liters. So now all I need to do is take the moles divided by liters, and I get molarity. So let's go ahead and do that. So I'm going to have, do I have space? I have a little bit of space here. So in this case, molarity, I have my moles, I have my liters. Let's divide them. So it's going to be moles of solute, 6.68 moles of my, forgot the Li2SO4, my lithium sulfate, divided by 2.5 liters. And I get, what's my answer? 2.67 molar. So 2.67, do I have space? Yeah. So 67 molar. So let me bring that in a little bit. So that's going to be 2.667 molar. So the capital M means molarity, molar. So they usually say 2.67 molar for the concentration. So that's the molarity of this particular substance or solution. Okay, next, problem number 2. I'm given 6.7 times 10 to the negative 2 grams of lead 4 acetate, and that's dissolved in to make a 3.5 milliliter of this solution. So what's the concentration? Now, a lot of times, notice here, they're just asking for the concentration. They're not giving you what way in which to express the concentration, right? They're not telling you molality or percent by mass or molarity or anything like that. In this case, when they're asking you for the concentration in chemistry, the assumption is to use molarity. So if they're not asking for the specific concentration, assume that they want it in molarity, because in chemistry, that's usually what we're going to have our molarity expressed, our concentration expressed in. So they're giving us grams. Again, molarity is moles of solute over liters of solution. Okay, So they gave us grams again. So we're going to have to convert grams to moles because we want moles of our solute. In this case, lead 4 acetate is our substance, our solute. So again, we need to convert that to a formula so we can calculate the molar mass. So we need to know what the formula is. So in this case, lead 4 is for the charge on the lead. Acetate, it has a -1 charge. So when we get the formula for that, the formula is going to be lead, which is Pb, and we're going to have our acetate, which is going to be C2H3O2, and we're going to have 4 of those. So there's our formula for the 4 lead acetate. Hold on a second. All right, so what's the molar mass? We got 443.2 as I calculated. So the molar mass of this is 400 and what did I say? 443.2 grams per mole. So there's my conversion factor. So I'm going to convert these grams into moles. So here we go. I'm going to have 6.7 times 10 to the -2 grams of my lead 4 acetate. So Pb C2H3O2 4. So this many grams over 1. Multiply that by my molar mass as conversion factor. So the grams goes on the bottom. So 443.2 grams of the lead 4 acetate. And 1 mole of the lead 4 acetate on top. So grams of the lead 4 acetate cancel out. Now I have moles. So I do my calculation and I calculate how many moles did I calculate? 1.51. 1.51 times 10 to the -4 moles of my lead 4 acetate. Oops. Okay, so there's my moles. Let me double check, make sure I wrote this down correctly. Okay, so I have my moles of my lead 4 acetate. Now I need liters. They gave me 3.5 milliliters. I don't want milliliters, I want liters. So let's convert that to milliliters. So I have liters. I have 3.5 milliliters of this solution over 1. Again, I'm going to use 1 liter is equal to 1,000 milliliters. So 1,000 milliliters goes on the bottom, 1 liter goes on top. Milliliters cancels out, and I get 0.0035. Oops, I don't need 2 decimal points. And that's going to be liters. So now I have my liters, I have my moles. So now all I need to do is go ahead and divide moles by liters. So molarity is going to be equal to the moles, 1.51 times 10 to the -4 moles of Pb C2H3O2 4, my lead 4 acetate, and divided by 0.0035 liters of the solution, and I get a molarity of 0.0432. So 0.0432 molar. So that's the molarity of this particular solution that was made. So I hope this was helpful in any way. If this was helpful, if you enjoyed this video, if you learned something from this video, if you now know how to calculate molarities, then by all means, please like this channel, share it with your friends, hit that like button down there. Make sure you subscribe to my channel, hit that notification bell. Also, when you do, make sure you click all so that way you can be notified by all the videos I put out. And also, make sure you put a comment down below. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me, and have a great day.